Okay, and I believe you can all see my computer, correct? You can see my screen?
Yes.
Okay, good. Thank you very much. So this is going to be an introductory workshop, webinar on hands-on equations fractions. This is Dr. Henry Borenson. If there are any technical issues, we usually don't have them. They'll be quickly resolved. This slide is not supposed to be here, but since it's here, at the end of the session, we will be raffling the hands-on equations fractions learning system. These are the pieces the students use to solve fractional equations. Since hands-on equations evolved from hands-on equations, and since Nicole and others may not be familiar with hands-on equations, I want to spend at least 5 or so minutes on the basic program. So hands-on equations is designed to mystify the learning of algebra. So instead of students knocking their heads against the wall, against the door, everything makes sense to them. And the children use certain game pieces. This is for level 1, the blue pawns, red cubes, and flat laminated scale. And the teacher uses a 3-dimensional scale in front of the classroom with larger game pieces. And the objective is to find the value of the blue pawn, and that value can change from problem to problem. So in order to give you just a taste of hands-on equations, I'm going to take you directly to lesson 3. So I'm skipping the prerequisite lessons. And if you're teaching gifted students, all of your students in the 2nd and 3rd grade will be able to solve these equations. Average students, probably you can begin in the 4th grade. So what I'd like to do is give you an example here from lesson 3. So this is the hands-on equations interactive application. And I'm going to go to lesson 3. And the children learn in the first 2 lessons that the x's are represented by blue pawns. So the way we read this is we read this as 4 x's. So we're going to place 4 blue pawns on the balance scale. Okay, this will represent our 4 x's. The plus sign is an operation to add or place onto the scale. So we're going to place a cube with the number 2. And on the right side, we're going to have 3 x's. And we're going to have a constant or a cube with the number 9, okay? So the blue pawns are called blue pawns or x's, and the cubes are called constants or number cubes. So at this point, in lesson 3, the students learn that since this system is balanced, if I remove a pawn from each side, I will maintain the balance. And we call that a legal move. And the children do this physically at the seats. They use both hands simultaneously. So they're doing the same thing we are doing on the blackboard, but they're doing it concretely. From here, since this side has a weight of 9, and this already has a weight of 2, so from lesson 1 of hands-on equations, they know that this pawn is a 7. If they wish, they can also, in the next lesson, lesson 4, they can learn that you can also subtract cube values. I can take away 2 from here, 2 from the 9, and this becomes a 7. So the value of the pawn is x is equal to 7. And in order to do the check, we reset the problem one more time. The best way to do that is to clear this scale, and then that way they don't get mixed up with the pieces that are there. So if we reset the original problem one more time, then we can do the check. Now, some teachers have their students do the check up here, but that's not advisable in the early stages. After the children have practice, they can do that. Initially, they simply reset the problem one more time, and then they evaluate each side to see if they have the same value. So here's what they reinforce their arithmetic. If each pawn is 7, I'm going to have 7, 14, 21, 28, 30. So if this side is also 30, that confirms that x equals 7 is correct. If this side is not 30, then the students have to figure out what they did, try to find their error. So 7, 14, 21, and 9 is 30, okay? So this is the idea behind behind hands-on equations. There are 3 levels of 26 lessons. I've given you an example from lesson number 3. And many lessons have a summary tab here. And these examples that you see here are the teaching examples that are in the manuals. And those of you who have been attending our prior webinars are aware that we have a virtual site for students. Until middle October, it's going to be free. So the students can work at home. So the teacher doesn't have to give them the kits to work at home during this period of remote learning, or even during regular learning. The students can be given problems to solve at home. So until another 4 weeks, this is available on a PC, Chromebook, and MacBook. Okay, so before I move on, Nicole, this is all new for you. Do you have does this give you a little idea about what hands-on equations is all about? Okay, very, very briefly. Okay, Nicole, you can speak, or you could, yeah, why don't you speak? That would be fine. Does this give you an idea of what hands-on equations is all about? Oh, you were to a training for it before. Okay, fine, very good. Okay, so let me go on then. Okay. So in the legal movement hands-on equations, we use both hands at the same time. And on the student laminated scale, the number cubes are facing upward so the teacher can easily see what the setup is. And the student here is moving the pawns down to do the legal moves. They clear the scale to conduct the check. Okay, so hands-on equations, then there is evidence that hand gestures dramatically improve the learning of mathematics. So now what we want to get is to our basic agenda for today, hands-on equations fractions. So many teachers over the years asked to extend the program to fractions, and that's what we did several years back. Okay, so the students will be using certain game pieces of flat laminated balance, fraction blocks, and the red cubes for level 1. The program can be used with gifted students as early as the 2nd grade after they've finished level 1 of hands-on equations, and with average students in the 5th grade. So before we do too much, we need to learn the relationship between each of the colored blocks. So you have these fraction blocks that you give to your students, and you ask them to place them on top of the yellow block, and they see that 2 of the red blocks fit on a yellow block. So you ask the students, what is the value of each red block? And they'll say 1/2. And we use this notation. We say if y equals 1, r is 1/2. And then you do the same thing with the blue blocks. So initially, they don't see this. The students put the pieces on here and they see that 3 fit. So if y equals 1, b is 1/3. And if the yellow, and you see that 6 of the green blocks fit the yellow block. So if y is 1, g is 6. So now, supposing y is not 1, but supposing the yellow block is an unknown having the value of y. In other words, yellow block is no longer 1, it's y. So would you text chat, please, what would be the value of the red block? It's no longer going to be 1/2. What is it going to be? Would you text chat your response, please? What is the value of the red block? Let me get the chat panel up here so I can see the responses. Okay, so what is the value of the red block? Would you text chat your response, please? It's going to be 1/2 of y. And what is the value of the Blue block, please, would you text chat those responses? Each blue block is what part of y? Each blue block will be. Responses, please. Be 1/3 of y, right? Because 3 of them form a whole. And the green blocks will be 1/6 of y. So I need you to focus on these relationships because we're going to be assuming them. So the red is 1/2 of the yellow block, the blue is 1/3, and the green is 1/6. And the way we write that is this way. Okay, so right now we're assuming that y equals 1. So r is 1/2, b is 1/3, and g is 1/6. But now okay, so this is what we just did. If y equals 1, r is 1/2, b is 1/3, g is 1/6. Okay, so I jumped ahead before. So let's go back here. Supposing the yellow block is 1, would you please text chat the value of the green, of the fraction shown in green? I need you all to write a fraction. The yellow block is just 1. What is this fraction in green? Remember that each green block was 1/6. So please write the name of this fraction. Okay, I have a couple of responses. How about the rest of you? Tiffany, Angela? I'm getting 5/6. Okay, since each green block is 1/6, this will be 5/6. What is the name of this fraction in red? Remember that each red block is 1/2. So what is this fraction? Okay, I'd like to see a response from everybody. What is this fraction here? How many halves do you see? It's 1.5 or 3/2. And how about here? What is this fraction? Remember the blue block was 1/3. So this one is going to be what? 2/3, okay? Okay, now if the yellow block has the unknown value of y, this is the question that you responded to previously, the red block would be 1/2 of y, the blue block is 1/3 of y, and the green block is 1/6 of y. And the children learned these relationships in a matter of 1 or 2 minutes because of the visualization here. Okay, so now I need your help before we get going to our first equation. In terms of y, what is the green figure? Please text chat your response. In terms of y, what is the fraction in green here? Five-sixths of y, okay. How about this one? What would this fraction be? In terms of y, this is going to be 3/2 of y, and this is going to be 2/3 of y, okay? So this is basic, so we need to make sure we're together here. We used a language of copies. The numerator of a fraction specifies the number of copies. It enumerates the number of copies of the given unit fraction. So 5/6 of y are 5 copies of 1/6 of y. So what we're going to do now is give you a taste of hands-on equations fractions, and I want to use the interactive whiteboard because I don't have my document camera has been misplaced and I cannot show you with the physical pieces, but I'll show you with the interactive application, which is very much the same thing. So I'm going to use the Smartboard application. Okay, so let's go here. This application is available for the Smartboard and also for Windows and Mac. So let's go over here. I'm going to go to lesson 1 and let me do this problem. Okay, so I'm going to ask for your help. I'm going to ask for your help here. We need to set up this equation. This equation says 2/3 of y are 16. Now, remember, which of these blocks is 1/3 of y? Please text chat your response. Now, I'm asking you basic questions because these are some of the questions you would be asking your students to make sure they're with you. So please text chat your response. Which of these blocks is 1/3 of y? Okay, everybody should be giving me an answer using the text chat panel. I'm looking for red, blue, or green. Which block is 1/3 of y? Okay, do you all see the text chat panel? Okay, there they are. It was hidden from me. Okay, blue. So this one is 1/3 of y, but the problem doesn't say 1/3 of y, it says 2/3 of y, so I'm going to need 2 of these blocks. Now there's nothing else on the left side of the equation. On the right side, we have a 16, so I'm going to need a 10 cubed and a 6 cubed. Okay, so I need your help. If 2 blue blocks are 16, would you please tell me what is the text chat, what is the value of each blue block? Okay, what is the value of each blue block, please? Okay, both of them are 16, so each one is going to be 8. Okay, so the blue block is going to be 8. Good. Now, if the blue block is 8, what is the yellow block going to be? So now you need to look here, and you need to look here. If each blue block is 8, what is the value of y? Please text chat your response. Each blue block is 8, so how much is the yellow block? Okay, can I see your answers, please? Okay, well, I see one answer. It's going to be 24, okay? So then the yellow block would be 24. And now we are ready to do the check. In this case, we didn't remove anything, so let's do the check. 8 and 8 is 16, and the right is 16, so the check is 16 equals 16. Okay, so that's an example from lesson 1. And you know that many of your students in grades 1 through 5, if you were to give them this equation, they probably would have difficulty with it. They wouldn't know what it means, how to get the answer, even to think it through. But here you see the process. We represent 2/3 of y. We find out the value of each blue block, and now we know that y is 24. Okay, so what I want to do is this. Okay, if you follow what we're doing so far, in the participant column, there's a yes button. Would you click on that, please? And if you're not sure what we did or you have a question, please click the no button. Would you try that? You should be seeing a check mark green or a red in the participant listing. Can you all find that? Okay, I see one check mark. How about the rest of you? Okay. Okay, Michelle, Nicole, do you see those? That's one way of getting feedback. Okay, so let's move on. Okay. So in hands-on equations approach fraction, we solve for the unit fraction of the unknown, meaning the red, blue, or green block, and then use that information to find the unknown y. So now let's go to lesson number 2. As in hands-on equations, each lesson introduces just one new concept. So let's now go to lesson 2. Okay, let's see if we can go to lesson 2 here. Okay. Okay, let's go to this problem. So again, I need your help. Which color block do I put on the left side, and well, first of all, which color block do I need in this problem? Yellow, red, blue, or green? Please text chat your response. Which color block do I need for this example? I'm going to be needing red. How many reds am I going to need for the left side? I need to set up 3 halves. Oh, okay, getting the idea. Okay, so this is 1/2 of y. This is 2/2 of y, and this is 3/2 of y, plus the constant of 4. Okay, we don't just say +4, we say a constant or 4, or a value of 4, or a cube of 4. And on the right side, we have a value of 19. So now you could use the same strategy used in hands-on equations. You could take away the same value cubed from each side. That 4 goes arrivederci. The 19 disappears, it becomes a 15. Okay, so now we are in a position to know the value of the red block. Would you text chat the response, please? How much is each red block? Okay, I see one. Okay, so I'm seeing the response of 5. Since 3 of them are 15, each one is 5. And if each red block is 5, what's going to be the value of the yellow block? If each red block is 5, what's the yellow block going to be? Yellow block is going to be 10. Okay. Okay, now to do the check, we reset the original problem and see whether or not both sides have the same value. So here we have 3/2 of y plus 4 is, let me get rid of, equals to 19. And now let's do the check. If r is 5, I'm going to have 5, 10, 15, 19, and this side is 19. So the check will be 19 equals 19, okay? So notice what we did. In lesson 2, we now added something to the left side. So now this is a pretty nice equation. I would wager, if I were a wagering person, that if I were going to almost any elementary school in the United States, grades 1 to 5, and I put this equation on the board, I'm not sure that there would be any children who'd be able to solve this, right? They wouldn't know what it means, they wouldn't know what to do, and yet here, in the second lesson, they're already able to make sense of a problem such as this. Okay, so what I want to do now is, let's try that again. Okay, again, can I see a check mark if you're with me on the participant list? Do we have a check mark? I see one check mark. Michelle, Nicole, can we give me a check mark here? Okay, so I think in the future I'll use polling. It seems to work better. Okay, let's go on. So a legal move is a move which leaves a balanced system in balance. So you could take away the same Q value from both sides of the setup. We may remove the same Q value from each side of a balanced system. So notice we could take away a 4 value from the 9 cube and change that into a 5 cube. In this example, you're actually removing a 4 cube from each side, but you don't have to rename a 13 in order to do that. You could remove it directly. So now we'll go to lesson 3, and this is more complex. So I think what I want to do now, I want to try something here. Okay, let's see how we do this. Give me a second. We have a student virtual site for hands-on equations fractions, okay? That's this one. This also has the code of algebra. Log in. Okay, if I do this, okay, I don't like the way that looks. So what I want to do here is go to annotate. Let's see if that looks better. Okay, a little bit better. Okay, so what I want to do now is I want to give control to one of you, and I'd like you to see if you can move the pieces and set up this equation. Okay, so give me a second here. Okay, Mish, let's see, can I get, hold on. Remote control. Okay, Michelle, I'm going to give you remote control. Okay. Would you see if you can move the pieces from where you are, Michelle? Let me get rid of this screen here. It's blocking my view. 1 second. Hold it. 1 second. Okay, would you see if you can move the pieces? You need Y first. Would you see if you can do that with your mouse? Okay. First of all, I need to do something here. Give me a second. Okay, there we go. Try now. See if you can move the yellow piece to the scale. Good. That's the Y. And what else do you need now? That's 1/3 of Y. That's 2/3 of Y. Good. And you need what else? You need the 3 constant. Good. And on the right side, you need what?
I'm not familiar with the 18. I don't know. Do you use the red for it?
Right, that's a constant. So it's a weight of 18. So you need a 10 and an 8. Use a 10
Okay.
cube and an 8 cube.
All right.
No, not a 1 cube. That's
yeah,
a weight of
okay.
1. That's a weight of 1. These are weights.
Okay.
Okay, very good. So that would be the setup for the problem. Let me just place these a little bit on the board here, but that's not needed. Okay, so now we have the setup. What would you like to do to solve? Do you see any legal moves? Is there anything you can remove from both sides to maintain the balance?
I could take a 3 out of both sides.
Okay, repeat after me. I can take away 3 value from both sides. Just say that.
I can take a 3 value from both sides.
Okay, try doing that. I think if you right click, it will remove it. Try right clicking the 3. Does it do it or no?
I'm not getting.
Okay, then move the 3 up higher above the scale. Okay, there we go.
Okay.
And remove the 8 and change that into a 5. Good. Okay, so now I need to ask our friends, we have a problem because on the left side in lesson 3, we have blocks of 2 colors. And when we talk about fractions, we use the term common denominator. Here we have fractions, different kinds of fractions. I need to have them of 1 color. So would you use the text chat panel, please? What can I do on the left side here so that all the pieces are of 1 color? Any suggestions, please? Text chat suggestions? Replace the Y with 3/3. Good. Okay, why don't you do that? You could move the yellow block away and put 3 of the blue blocks in its place.
Oh.
That's okay. That's okay. 1, 2. Good. So now on the left, you have 5 blue blocks equal a total of 15. So how much is each blue block? 5 of them are 15. Each blue block is what? Your text chat your response, please. Okay, I think Paula, thank you for your comment. I think we're recording. So each blue block is going to be 3, right? 5 of them are 50, so each blue block is 3. Would you type the answer up here, y equals 3? See if you could type up there where it says type here, above the equation. See if you could type y equals to 3.
Oh.
Y equals 3. Good. Okay, now what we want to do is do the check. So let's go over here. If you see this, this clears the board. So we're going to click on the bottom circle here.
Bottoms.
To the right of the bottom scale. No, not that one, not that one. Lower the mouse. Further, to the bottom. There, click on that. Okay, now set up the original equation one more time so we can do the check. So we have y plus 2/3 of y plus 3.
With the
With the pieces, right. Y plus
Okay.
2/3 of Y. We call this the original physical setup. We always go back to the original physical setup to do the check. Y plus 2/3 of Y plus 3 equals 18. 10 and 8. Okay, so now we need to do the check. Okay, so let me get somebody else here. Thank you very much for your help with that. Let me get somebody else to assist me here. Nicole, do you think you can help me here? How do we do the check? How much is the yellow block? Are you there, Nicole? Whoa, what happened here? 1 second. I lost, let me get this back up. Okay, 1 second. Okay, here we go. Okay, so let's see. Oh, Nick, yeah. Okay, so let's do the check together then. We said that Y is 3, so each blue block is going to be 1, right? Because you had 3 of them. We could have actually written over here that the blue block is equal to 1. So for the check, we got 3, 4, 5, and 3 is 8, and this is 18. So something is not working out, right? Something is not working out. So can somebody tell me where, if it's not working out, why it's not working out? Okay, so the reason it's not working out is apparently when we had 5 blue blocks were 15, that meant that each blue block was 3. Not Y is equal to 3, but each blue block was 3. Okay, so I'm going to go back here so I can show you where we were, okay? So this is what happens. When the check doesn't work out, we got to go back. If you remember, a few seconds ago, we had 5 blue blocks worth 15. Therefore, each blue block is 3, and therefore Y is going to be 9, not 3. We got these mixed up. So now we are ready to do the check. So I'm going to clear the board here and set up the original problem. So you have Y plus 2/3 of Y plus 3 is equal to 18. And now let's see if it works. So if Y is 9 and B is 3, we have 9, 12, 15, 18, and this is 18. So for the check, we have 18 is equal to 18, okay? So that gives you an idea of how we work from lesson number 3. So let me clear all drawings. Okay, good. Okay, this is a video of a 2nd grade student solving an equation. So let me see if I can share that video with you. Okay. If you could help me with this, Pablo, would you please place a Y over here?
Yeah.
Good. Now, the problem says to add 1/3 of Y. Okay, we also need a +1. Wonderful. Now all of that is equal to 9. Okay, so far we have this set up for the problem. Do you see any legal moves we can perform to simplify? Okay, what would that be? Tell me what you're doing before you do it.
I'm taking a $1 and then I'm going to change it to an 8.
Okay, good. Why don't you do that? Okay, now the problem we have now, it's good that we have the cube by itself here, but here we have 2 colors. We need to have one. Wait up, before you do it, tell me what you're going to do.
I'm going to take out this and exchange it for 3.
For 3 what?
For 3 thirds.
For 3/3. Okay, why don't you do that? Take out the yellow block. Exchange it for 3/3. Okay, now you end up with 4 blue blocks worth 8. So how much is each blue block?
2.
Now, do you know another name for the blue block?
Yeah, a third of y.
Okay, would you please write 1/3 of y equals to 2, okay? Because we just said the blue block is 2. Now, we need to solve for y, so the question is this. If the blue block is 2, what would the yellow block be?
6.
How do you know?
Because 3 of the thirds fit on y.
Say it again.
Because 3 of those fit
3 of those fit here.
Yeah, and each of them is 2, so it would be 6.
Okay, please write down y equals 6. Okay. Chava, you're doing very nice. However, we now need to check the problem. Would you clear the board, clear the pieces, and let's set up the original problem one more time. So you have y plus 1/3 of y plus 1 equals 2, 9. And let's see if both sides have the same value. Tam, 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 tam. Okay, y is 6.
6.
And 1/3 of y is 2. So
8.
this is 8 and 1.
9.
And this side?
9.
Okay, please write 9 equals 9 for the check. Okay, you did a nice job with that. How old are you, Chava?
7.
7, very nice. Okay, that was a beautiful video. Do you all agree with that? Nice video, doing a nice job. Can I see your response on it in the text chat panel? Did you enjoy that video? Okay, and I assume you could all hear her, correct? Okay, good. All right, so the webinar is going, and this is an introductory webinar, but later on the students, the equations become more complex, but the strategies are the same. They can always remove the same value from each side. This is now a 6th grader. I won't show you that video. Here you're working with fractions with different denominators. What I do want to do though is show you one example with the green cube. So let's see if I can do that, okay? And then we'll wrap up there. So to go to the green cubes, I want to go to level 2. So let's see here. Level 2 are the green cubes. So let me jump to lesson 9 or 10. Okay. All right, good. Okay, so this is lesson 9, and let's see how we do this. 3/2 of y, we already know, plus 10. Now there's a lot of stuff here, and all of that is only equal to 4. Okay, so we were not able to do that with level 1. Tell me something. Based on the fact that all of this is equal to 4, what does that tell you about the value of the red block? I'm looking for one word. Does anybody know what that word is? What does that tell you about the value of the red block? If the cube is 10, I'm not looking for a number, I'm looking for an adjective. What must the red block be in order to get down to 4? It must be what kind of a value? Positive or negative? It must be a negative value. Okay, so there are a few ways to solve this problem. The simplest way is to use the addition property of equality. Just like we can take away the same value from each side, we can add the same value to each side. And once we do that, a positive 10 and a negative 10 are equal to 0. Okay, so I can remove that. Now here you have a positive 4 and a negative 6. So what the students do, excuse my voice, one second. what the students do is they ask themselves, do I have more reds or greens? Well, obviously I have more greens, so a positive 4 and a negative 10 is going to be a negative 6. Okay, so this and this can be removed and replaced by a negative 6. And this, as we said, is no longer here. So now we are ready to write the answer. If 3 of these red blocks are a green 6, that means that each one is a green 2, or each one is a negative 2, okay? So each red block is a negative 2, therefore 2 of those would be a negative 4. And now to do the check, we go back to the original problem. So I have 3/2 of y plus 10, positive 10, red hot, equals to a 4, a positive 4, a red 4. And now in order to do the check, the children normally would begin with the 10. And since the red block is a negative 2, we have 10, 8, 6, 4, and this is 4, so the check is 4 is equal to 4. Okay. Okay, so this then gives you an idea of how the hands-on equations fractions program works. This is the individual set that's available for the teacher. It has the instructional manuals, the worksheets, one set of game pieces, and this is what a class set of materials look like. Each child has the laminated scales, pawns, not pawns, cubes and fraction blocks. And we have an application for the smart board, for the whiteboard, and also as I just showed you the virtual student site. We have workshops, but because of the pandemic, we have not been doing those. Okay. Okay, I wasn't really planning on doing a raffle here. I didn't set that out. I'll tell you what, if any of you want to purchase one of the hands-on equations learning system, instead of the raffle, we'll give you $10 off or something like that. I don't have the raffle set up. Normally what we do is we have a number selected in advance, and I just did not delete that. Okay, I'd like to get some feedback from you, please, before we wrap up. Let's see, who would like to tell us? Angela, would you like to share your thoughts? Did you find this of value? You could speak, please. What are your thoughts about what you saw here? Okay, do I have a volunteer who would like to share what they thought about this webinar? Or you could text chat the response if you prefer. Nicole, can I have your thoughts, please?
Yeah, it was a good refresher that I needed, and I have not seen hands-on equations with fractions, so it was really good. Thank you.
Okay, do you see how it's intuitive?
Yes, definitely.
Okay, Michelle, your thoughts, please. Michelle, you want to share your thoughts? Or Paula? Okay, I'll tell you what, you guys are shy maybe, I don't know. It's okay, just text chat, your text chat panel is also good. 1, 2, 3, who's 1, 2, 3? What's your name? I don't know who 1, 2, 3 is. Okay, who was speaking? Somebody was speaking.
This is Paula.
Good.
I was going to say thank you because I haven't seen the fraction pieces as well, and I do have this at my school, and I utilize it quite a bit. So it was interesting to see this and to see how you've created a digital portion that we were all trying to, mastermind and figure out how we could you know, create something like that to use this. So it's nice to see that you have that available now. So thank you.
Right, it's complimentary through, on our website. Let me show you where you could find this. On the Borenson website, on the Hands-On Equations site or the Borenson site, if you go to products, the last item is called Student Virtual Portals. And if you click on that, you'll be given the links to the 2 virtual portals, and that's complimentary through October 15. After that time, you're able to purchase it for the year, $25 for one teacher. If you're a teacher of the gifted with up to 100 students, it would be $50. So but until then, it is available. We had a designer do this one is, let me get the fractional one. Yeah, as you see, this is very sophisticated. The designer did this and he did a very nice job with it. Okay, the virtual teaching of hands-on fractions. I would begin, once the students have finished level 1 of hands-on equations, they are ready to go to the fractional work. Okay, so right now we're wrapping up the webinar. Let me know if you have any questions or comments, please, that you want me to respond to. I appreciate your joining us. And I believe we have a recording of this, so I'll be happy if it comes out to send it out. Okay, any other questions for me? Okay, so if not, oh, by the way, I wanted to mention one more thing. We have been working on this product here. Can you see my screen? This product, we expect this to be available in the next few days. These are the hands-on equation slides for the worksheets for hands-on equations, okay? It looks like the price of that would be $25. Can I see from the people who are here, do any of you think you would be interested in that? I think this will be available in the next few days. These are the slides for that you could use with Google Classroom. Okay, any thoughts on that, please? Okay, so one more time, do any of you think you'd be interested in those, in the Google Slides of the worksheets, or that your district would be interested in it?
I think some of us are saying yes in the chat.
Oh, you are? I'm not
Yes.
seeing it. I wonder why I'm not
Yeah.
seeing it. Why am I not seeing it? 1 second. Okay, fine. Okay. Okay, very good. Okay, so again, thank you all for joining us. And I appreciate your being here, and I hope you have a successful year, and all of you keep safe. So thank you. Have a wonderful day.
Thank you.
Okay, bye-bye.